Okay, in this video we are going to solve this problem right here, and we want to calculate the derivative of this function using the definition of derivative. And off to the side I have the formula for the definition of derivative. So let's begin. So we can say the derivative of f of x is equal to limit as h approaches 0. Now it says f parentheses x plus h. So wherever you see an x, you're going to replace it with x plus h. And I'll show you what I mean by that. So we'll have 2 parentheses x plus h, close parentheses cubed, minus 4 parentheses x plus h. Now here we have a minus f of x. So you put a minus parentheses and you'll copy what you have. 2x cubed minus 4x. Now the whole thing is being divided by h, so the whole thing is divided by h. The next step is we can kind of clean this out a little bit. So the derivative of f of x is equal to limit h approaches 0. This is saying 2 times x plus h cubed, which is x plus h times x plus h times x plus h. So we can rewrite it like that. So we have x plus h times x plus h times x plus h. Now this is saying minus 4 parentheses x plus h, so you have to distribute the minus 4 to both pieces. So you'll have a minus 4x minus 4h. Same for this minus, you got to distribute it to both pieces. So we'll get a minus 2x cubed minus 4x gives you a positive 4x. All over h. The next we can expand 2 of these pieces, so we'll just do that right now. So the derivative of f of x is equal to the limit as h approaches 0. So we have 2 parentheses x times x is x squared, x times h is xh, x times h is xh also. So we have 2xh. And h times h is h squared. But we still have this piece, so we have to expand again. Now here we have a negative 4x, here we have a positive 4x, so they cancel. And we still have this negative 4h minus 2x cubed all over h. So next we will expand again, so the derivative of f of x is equal to the limit as h approaches 0. So we're going to have to distribute these 2 pieces. We'll still keep our 2. So 2 parentheses x squared times x is x cubed. X squared times h is plus x squared h. 2xh times x would give us 2x squared h. 2x squared times h would give us 2xh squared. H squared times x would give us h squared x, and h squared times h is h cubed. Close parentheses. We still have this piece, so minus 4h minus 2x cubed, all over h. So again, we want to get the derivative of f of x, and that's going to be the limit as h approaches 0. So now we have to distribute this 2 to all of the pieces in the parentheses. And so each one of them we have to multiply 2. So we're going to get 2x cubed because of this. 2 times x squared h would give us plus 2x squared h. 2 times 2 gives us 4, so 4x squared h. 2 times 2xh squared would give us 4xh squared. 2 times h squared x would give us 2h squared x, and 2 times h cubed would give us 2h cubed. And then we still have this piece, so minus 4h minus 2x cubed divided by h. Now we can kind of combine like terms. So this is 2x squared h, this is 4x squared h, so they're the same. So we would get 6x squared h. This is 2h squared x, this is 4xh squared, just the reverse order, but it's the same. This is h squared x, x. So we can combine these two also, and we would get 6xh squared. This is a 2x cubed, and this is a negative 2x cubed, so they're canceled. And so now we're going to rewrite this. So we have the derivative of f of x is equal to the limit as h approaches 0. Now, each of these pieces contain an h. This contains an h. This contains an h squared. This contains an h cubed. This contains an h. So we will factor out an h, parentheses, 6x squared. 6x squared times h is 6x squared h plus 6xh, because h times 6xh is this piece, plus h times 2h squared would give us 2h cubed, minus, so this is a negative 4h, this is an h, so just negative 4 all over h. So the h's cancel, and now our next step is to plug in the value of h is approaching 0. So wherever I see an h, I'm going to put a 0. By doing this, this would cancel and this would cancel. And so our final answer would be 6x squared minus 4. So 6x squared minus 4, and we can box in this answer. And that's all we need to do for this problem.